two A's. Yes, so E is correct. The atmospheric pressure at sea level in PSI. In that video, the guy who was calculating CFM was in Florida or something, so he was at sea level and he was 14.7. That number is going to change, which we'll show in your notes today. It will change depending on your location. So cool. Good job, squad. So let's continue on with our notes for compressed air. So in the YouTube video, they talked about the CFM for a compressor. So we can determine what our cubic feet per minute are for a specific air compressor that we have. Pretty important, so we can see if our air compressors are maybe getting old over time or if there's a leak or something. So let's go ahead and write those equations down and make it a little bit more clear from what the video had. So our Q, that's our CFMs. That's equal to the volume of your tank times the pressure reading. The pressure gauge reading you get for the second part minus the pressure gauge reading you get at the start. So when you turn on your air compressor, that first reading that you get is your pressure 1, and then you time and you wait for it to fill up. You're keeping track of time, and then when you stop it, your pressure 2 is that pressure after you've spent some time letting it fill up. So that's all over the time that you spend filling up that tank. Okay, on this equation, there's some other pieces here we want to add so we can convert and get what we want. Okay, so if we have, say, gallons and we need to get to our feet, we've got a 7.48 gallons per 1 foot cubed as a conversion factor. Our next conversion factor gets us to our standard pressure and volume. So that's that 14.7 in our clicker question. Okay, so that 14, that 14.7, that's PSI where you're at, and that's equal to that 1 ATM. Okay, so this is getting us to STP here. So this value, that's going to change with location. Okay, and then we can get our minutes to seconds depending on what we are measuring in. So all these blue numbers are things that can change, but our conversions with this original equation written in black. So let's write down what all these things are. So our Q, that's our CFM. So got a foot cubed per minute, cubed foot per minute, whatever. V is volume. I officially hate this. Yeah, that's in gallons. Our pressure gauge 2 that we read is the second pressure reading. That's the PSI. I guess we put a G on there because it's the gauge. The first reading that we get is the first pressure reading we read. And then T is that time. Ooh, that's gross. T is time. And I'll say in seconds here because I have this conversion added on. Getting that in seconds to get to minutes. Okay, cute equation. Got it? So there's a tool for you. Let's go ahead and do an example problem. So, you got your mine site, and there's an adjacent project going on, and they completed their project, and they say, hey, we have this 120-gallon tank. We don't need it anymore. Do y'all want it? My first gut reaction is, why are they giving me this tank? Is it really bad? Maybe. So it's currently empty, and you look at this and it says the specs on the tag, okay, it can achieve 35 CFM at 100 PSI. So you're like, okay, I'm gonna test this tank out because I don't wanna just take it and it have a leak or be something I don't want. So you're gonna turn it on and you say, okay, time is 380 seconds to reach 100 PSI. And you're like, okay, cool, that's enough time, I'll turn it off. And you know that your mine is located at 4,000 feet above sea level. Okay, I'm gonna give you all 5 minutes to try to solve this yourself, and then we'll go over it in class. So determine the compressor output in CFM, and then if you deem this compressor to be usable on your site. Okay, give you 5 minutes to work through it yourselves. Have fun. Oh, you can also work with a partner and chat about it too, by the way.
Since that's at sea level, 40,000 feet above sea level. I'm just gonna look that up. Yeah, it will. PSI. What is it? 40,000? 4,000 feet.
Got it?
This is 100 minus 0.
Goes over there?
Yeah, we gotta like find it and fix the size.
Yesterday.
Anyone that's doing garage is doing
What's the equation?
It's like
Equals volume times
So it's the machine work. Yes,
What are we talking about?
Or asking for like okay. Yes.
Yeah. So log of 0 is 14.
Why is there
Well, log of
That
14.
made me change.
Yes, so
Why
this
does it convert to that?
is gonna change. Because this is at 0, yeah, but you're at 4,000.
Yeah, that
This
is
number is gonna
feet
change.
squared or feet cubed.
Knowing your elevation goes up.
How does that turn on?
You're right. That is what you wrote.
Yes.
It's 12.7.
It's not working.
So,
Awesome. Okay, let's go over the problem together so we all have it down. There's a couple different ways to solve it, so we got a couple different varied numbers, but that's totally cool. So we're going to start with that original equation, our Q, V times the pressure gauge reading of 2 minus the pressure gauge reading of 1, all over our time. Okay, so it said our first and second readings. So we started at 0, and we got up to 100 psi. Okay, so we'll have 100 psi minus 0 psi. And then we need the volume of that tank. So we looked at it and it said, okay, it's 120 gallons. 120 gallons. Okay, we measured the time it took to get from pressure 1 to 2, and that was 380 seconds. Okay, I need to add some conversion factors on here though. So I'm in gallons, so I need to get to cubed feet. That's that 7.48. Gallons is 1 foot cubed. And then I'm not at sea level anymore. So I'm not at that 14.7 PSI. I'm now at 4,000 feet above sea level. So I can use the equations we went over last class, or you can Google it. That's also a thing you can do. So I Googled that and it came about 12.7 PSI, 1 ATM. So online resources are cool too. I'm happy some people used equations from last class. That's great. And then we have seconds and we need to get to minutes. Okay. Sum that out, we get about 20 CFM. Okay, second part of this question. Do you deem this compressor usable on your site? Let's hear some answers. What do you think?
Depends on the use.
Depends on the use, true, yeah. If you need more, then yeah, you'd want something different.
But it's free.
Say it again?
It is free.
It is free and it's still pretty good. Like we calculated it has a 20 CFM, but what does it say on the tag?
It's not a spec.
You're right, yes, it's not up to spec. So it's not exactly that 35, but it's still really good, okay? There's not a huge difference between these two numbers. So would you keep it on site?
Honestly, no, because somebody might be trying to screw you over.
Yes, Rob's taught you well. That is true. However, an 120-gallon tank, I looked it up, they cost about $1,500, the tank itself. So if the tank looks pretty good, like maybe you keep it for that. If it is running and you have the compressor and everything on it, that whole setup's about $3,000. So I don't know, maybe you could sell it, make some money off it. It's still got some monetary value. I would keep it on my site. If it's kind of working, I'd use it on some tools. Cool. What questions do you have with that? Yeah.
Why are we converting into atmospheres?
Yeah, so this is a little goopy thing here. It gets you to standard temperature pressure, STP. So if you go through all the units and the derivations, it works out with this chunk here. I won't go through that because it's messy with the units. But yeah, this is our 1 ATM STP, standard temperature pressure. Yeah. Okay, cool. We've got compressors. We also have line losses. So what does this mean to you all when you hear line loss?
Losing pressure over distance.
Say it again.
Losing pressure over distance through the line that's too small.
Yes, exactly. So you're losing pressure, losing pressure in your line because it's really long due to friction. So there's a quick and dirty equation that we can use. It's actually pretty good, which we will use for estimating our line losses. Okay. So, our change in pressure, or our line loss, what pressure we're losing, that is the pressure 1 in absolute pressure. Okay, very key. This is our absolute pressure that we're using. And that term is squared, minus the second absolute pressure squared that we get. And that is our Q squared, or the quantity of free air we're using, times the length over 2,000 times the diameter to the fifth. And you'll see this is our quick and dirty equation with just this 2,000 in the bottom. We'll write our components down here. But you'll notice, as we said before, L, length at the top of this equation, the longer your line is, the larger your pressure drop is going to be. you're gonna lose.
Bless you.
Bless you. Okay. Oops, I might have done this a little wrong. Yeah, so our delta P is actually P1A minus P2A. So I guess that doesn't really check out. So it's just the magnitudes, or not the squares. It's just the straight up values minus from each other is that change. Okay. So that delta P is the pressure drop. That Q is the quantity of free air. That's in CFMs. L is the length of line. And this is in feet. D is the diameter. Oh my. And that's in inches. Okay, so these units are very important because they tie into that 2000 term that's factored into the equation.
Pressure is still in
Yeah. Yeah. Okay, so length is in feet, diameter is in inches, and that's because this conversion factor takes that into account, that 2000 piece. All right. Does anyone need this up for another second?
So, what you initially wrote wrong, is it delta P squared equals that?
I guess it would be. Yeah, if you squared
That
everything, had
wouldn't be
everything
how that
squared.
works.
No, it's not.
Cause then you'd have like a P1A times P2A.
Oh, yeah.
So then what's the
No,
value
it
of
was
the pressure drop?
It was just.
The value of the pressure drop. Yeah, this pressure drop here is just your initial value. So if you had your line and you're able to measure the
Okay.
pressure at either end, you subtract those to get the difference.
It's just separate.
Yeah, they're separate. Yeah. Good question. I'm sorry I messed that up. Okay, so there's your tool. Let's do another question here. So at your mine site, you know that your equipment needs 80 psi, G, so that gauge pressure reading, at 4,200 CFM to run effectively. Wow, that's a lot. Your pipe is 6 inches in diameter. Your mine is at sea level. Oh, nice. And your pipe or your hose is 2,000 feet long from the compressor to the equipment. So if you had compressor and you had 2,000 horizontal feet of pipe, what's the required absolute pressure at the air compressor and the pressure lost in the line?
So we would be calling 80 PSI GRP 2A, right?
Yes, what you need at the end. Yes, absolutely. Okay, I'll give you all 5 minutes to try to crunch through this on your own.
salted and got the exact same pressure.
Yeah, okay.
That's weird. No, it's I think that's how that should
The
work.
numbers. They gave me the option to drive with it. They like,
Because you know how it is, where it's 14, you can convert it to absolute pressure.
I thought,
Yeah.
It gives you gauge pressure, not absolute pressure.
So maybe 14, 15 hours.
So atmosphere.
Yeah.
Yeah.
Oh yeah, that's like fucking silly.
yeah, it's way. You want G, minus 14.
You're not looking for one.
So you lose 30 PSI.
I will. 2.3. And then I'll simple and I'll loss it. P. You want them to be 2.
Well, at the pump was like, no, it's not his fault. Nobody knew that there was a valve closed on the line coming out of the pump. But he opened that and there was so much air in the line, that it forced all the air in the line. And that's why water was coming out of your exhaust.
I was like that.
Yeah, that ain't good. That's not how that shit's supposed to work.
I'm gonna just gonna say no, before everyone makes it.
I got new steel stuff like this. I got my own problems to deal with.
Well, I just want we're trying to blast that bitch. I got one stick on my face. I think we're gonna get her out. Because you can get her out. It's just it's gonna be.
I hope Lee is over in my room.
You're right.
But I might steal your jet like enjoy those lunches before all schools come. So you can go out.
I did, I don't like
I
it.
make some kids put it all over your head.
It's very,
I been with black card. Jacob don't want anything to do with that. And Adi just wants to be pushed as a little stuck.
this,
Is Lucky Friday?
is it?
Is it on Google Maps?
Yeah, that's the highway. It's got, 4 stops in one picture. No reviews.
Is it going to buy it? Yeah, you forget.
106 PSI compressor on 11.3 long. Is that right?
I don't know. What do you
I
think?
think so.
106.
I screwed up, so I'm working on it.
It's on it. It's okay.
106.
These numbers you call, they just call a list.
Yeah,
Yeah,
so
that
I
actually
left
was.
it in the A's. It should be an absolute.
Whose office 200?
You would just add your atmosphere.
Good. Yeah, I talked to.
Oh,
She's like, I was like, oh yeah, we're going out to in March. She's like, oh, I can organize a tour for you guys.
They own it.
Yes.
They post those
Are these two
videos.
separate?
Here we go.
So many weird things.
No, these are the same variable, so this A is still the absolute. And these are the same variable.
so that it's a
depth.
So that you can divide by less.
Yeah, it's less.
That's all we got. From the West Coast. It's like the only city
Yeah, that's what I'm hearing too.
Oh, it's green.
green, dog. Hold on.
Yeah, this is the West.
Green's too green.
So it's real green. You think you gotta live like or in Texas.
It's a big old mud in the middle of the city.
Unheard.
Oh, it's wet. West of the city is like a bunch of.
Yeah, so we'll go over all this stuff that you can have done there.
That is the weirdest little part.
You are adding, that's good.
It's like a
You
moat.
wanna add to 14,
The clouds, but it's.
7. Yeah, cause this is engaged, so you wanna go to absolute.
I was thinking kangaroo.
Yeah, you should go over it here.
Everything was there. I was talking to her and she's just yeah, I was like everything else.
In about 6 months, the Calgary Health Campus diagnosed 92 patients with Bennett malaria condition.
Alrighty, let's go through this problem here. Okay, so our equipment needs 80 psi G, so we're reading that at our equipment. We need to always translate to the absolute pressures for our line losses, so let's start with that. So we'll say the pressure, we're gonna say that's 2 because that's further or at our equipment down the line. Okay, that's the absolute is going to be the barometric plus that gauge pressure. So we know what the gauge pressure we need our equipment to work at. So that's that 80 psi G. And then what's our barometric pressure?
14.7.
Yes, and that's because we're at sea level. So that number can also change. Okay, so our P2A ends up being 94.7 PSI. We'll put an A at the end of that. So we need an absolute of 94.7 PSIA at the drill site. Cool, we're finding things. Let's tap back to that equation that we wrote down before. So that would be our P1A squared minus P2A squared equals Q squared times the length over 2,000 times the diameter to the 5th. And we now know what our 2PA is, and we need to figure out what this first pressure is. Okay, so let's solve for that. So P1A will equal the square root of that Q squared times L over 2,000 times D to the 5th plus P2A squared. Following that? Is that what y'all did? So far, so good? Okay, so we have our variables. It gives us Q. So that Q is that 4,200. Okay, so we can plug that in. Our length, gave us the length, right? 2,000 feet. Gave us the diameter, 6 inches. And then we have the pressure at our second drill site point in absolute. Okay, so when we plug this in, what do we get for P1A?
106.
106? What's the units of that?
PSI.
Cool. we have the absolute pressure at 1, but it's asking us, okay, oh wait, no, it says what's the absolute pressure? Yeah, that, I guess that's the answer. So that's the absolute pressure, but our gauges are not in absolutes. So how do we change this into now the gauge pressure that we need to read at the compressor?
Just subtract 14.7.
That's my dude. Okay, so that 106 minus, again, that 14, or that one up here, 14.7. What do we get with that? 91.3. 91.3 kBCO. Okay, so that's the reading at the compressor. Cool. Awesome. Last question is here. And what is the pressure loss? Okay, tapping back to that original equation, our loss is equal to that first absolute pressure minus the second absolute pressure, which we have found. So we said that's 106. And then the piece that we needed at the equipment in absolute is 94.7. And we get, what is this, 11.3?
Yeah.
Yeah, that's what we got. That would be in PSI. That's our loss there. Cool. What questions do you have? Line losses.
Does it change based on what kind of hose you use? Use like a bull hose versus a steel pipe versus.
Yes, it does. So we use the generalized, like quick and dirty equation. But if you have something that's more like, or less friction resistant or like different material, you can use a more complicated equation for that. This is like very general with laminar flow, what you'll see at the site. Yeah. Cool, good job, team. All right, one more piece to cover before we're done, which is horsepower. How much horsepower do y'all need for that air compressor? Okay, so there's an equation we use to calculate our brake horsepower. So we call that BHP, brake horsepower. We have this cute term, 144 out front, just because. I'm gonna go ahead and write the equation up because there's a lot of components, and then I'm gonna have y'all guess what you think the variables are. Okay, so we've got an N, we've got a P1A, we've got a Q, we've got a K, we've got a P2A over P1A, and that's to the power of K minus 1 over N times K, and this is all minus 1, and wait, there's more! It's all over, what is this, 33,000 times K minus 1 times little n thing. Oof, okay. So this is our equation for brake horsepower. What do you think these variables are?
I guess K is a constant.
K is a constant. Yes, does anyone know what the constant is?
I don't know, but it's probably German constant.
It's probably German. Yes. So K is the adiabatic expansion coefficient. Great. So that's just for air, for when heat is not leaving or coming into the system. So K is a constant. It's 1.41.
Call that the adiabatic what constant?
Yeah, I'll write it down. 80. I can't even say adiabatic. Adiabatic. I think that's how you spell it. Expansion coefficient. that's for regular air. So it will change if you have other gases. Yeah.
Is that a 33,000 or 3,300?
Yes, that is 33,000 on the bottom.
Awesome, thank you.
Sorry, my handwriting's crap.
No, you're good.
Okay, cool. We picked out a K. What do you think the next, or one of these other variables is?
Q is probably CFMs.
Yes, good job. Q. And specifically, that's the volume of air at your atmospheric pressure. Cool, what's another term?
That times efficiency
Which N?
on the bottom.
This one?
Yeah.
Yes, that's the efficiency. Efficiency of compressor, and we usually have that between 0.8, I don't know, a 9 or around 0.85. Those are common. Common efficiencies, like you've seen 0.7, 0.8, sometimes 0.9, but 0.8's usually what you'll see. Cool. What's another variable?
P2A, P1A, that's the absolute pressures.
Yep, you got it. So let's go. So I'm saying that's the absolute initial atmospheric pressure. Okay, and then same for P2A. Okay, so if you're calculating that brake horsepower, you need two pressures in that air compressor. Okay, another variable. What do we got left?
I think it's big N.
Big N. What is big N?
It's like the number something.
Yes, yes, it's the number of compression stages. So in different air compressors, you can have different stages to get more compression. And that's in one of your YouTube videos you'll watch this week. So N, big N. Number of compression stages. Cool, that's all of them, yeah? Sweet, so we have all these terms, we have this chunky equation, but we can double check ourselves with what we have online. I'm hoping I can get this, maybe I can. Okay, can't click on that link. Anywho, Engineering Toolbox is a great use where you plug in your variables. You're like, okay, I have this CFM of my pump and I've read these pressures. I know my efficiency is 0.8. You plug it in and it gives you your brake horsepower. It's really great. Great tool to have. On that website, they show you the curve. They use a nomograph. And so that big N term that we were talking about, they have different plots for if you have a single, a two-stage, or three-stage air compressor. And those are basically the number of chambers that you have in order to compress the air. So there's these different curves that they have theoretically and experimentally proven. And if you have certain, air pressure, you can determine the CFM, the horsepower per CFM of free air. So that online tool uses graphs and experimental and theoretical data to give you that horsepower. So feel free to use the equation, but I would use the online tool. I think that's it for today. Yes. Any other questions before you head out? Oh yes, so we have actual lab this Friday. We'll be at EMI, so make sure to wear pants, closed-toed shoes. If you have goggles and ear pro, bring those. If not, we have goggles and ear pro. On Canvas, there's groups made for you all already. It's called like compressed air lab groups. And we're gonna be going in shifts. So we'll have 3 different time slots where we'll have, I think, groups 1, 2, and 3 going from 9:15 to 9:45. And then the next 3 groups from 9:45 to 10:15, and then the last 3 groups from 10:15 to 10:45. I'm gonna post that on Canvas with the group numbers and the times. So you'll only be there for half an hour, but we are doing what our first question was today. So we had calculating, figuring out what the CFM is for different air compressors. Okay, that should be posted on Canvas, the lab, so you can take a look at it beforehand. But yes, only show up at your allotted time, and I'll post that when you should show up on Friday. Yes, I think that's it. Cool, make sure to wear pants and closed-toed shoes. Sweet, we'll see you there.